take your chairs if you like.
Good morning, everyone.
Keith, hurry up. Okay, so previously it was left hand, right? Now we use the right hand. Take out your right hand.
Take out your right hand.
Okay, so apparently, guess for, you can put on the table. Guess, I said this is for generator, right? The one we learned before is motor. Now what we learn is generator. You can compare these two. Basically, they are like a mirror. Like you still have these first three fingers, and you make 90 degrees for each of them. Okay, so like that. This is the right hand. So similarly, the first one is F, second one is B, this one is I. Some people call it M instead. When I was a student, I call it IBM. I go reverse because IBM it's still a company making computers. So I call it IBM. I think you don't know. Anyway, so you can. Never mind. It's a company in US. Never mind. You can still call it FBI if you like. I mean that should be sufficient. The most important thing is for generator. What do you give them initially? Among these three, you give them what? You give them motion because like the crane that you make, you have motion and then you need what?
Magnetic field.
Very good. You still need the magnetic field in order to generate the current at last, right? Remember what you learned in year 9 about like fossil fuel, nuclear power plants, you drive the turbine. Yeah, actually in the turbine there are magnets, there are magnetic field inside so that you can generate current. Here is the same thing. If you remember this setup, this is basically similar to what we did in the previous week. But instead of power supply, I have this here. Do you know what is this? It's not a voltmeter. It's an ammeter. And you can see there are only two holes, a bit different from what you use. It's called micro ammeter. That means what? Very, very small. Right, very good. You can see 20 to 100 micro amperes here. So it's 10 to negative 6 times. Doesn't really matter, you don't need to memorize that. But the current that it generates is so little. That's why I need to use this. Otherwise, if you use the normal ammeter, you cannot see anything. Actually, this one, it's very hard for you to see anything. So later on when you can't see, you can come closer to me. So what we can do is, you can look at this one. Make sure you can see the needle. I don't think the one at the back you can see. When I move this wire between the magnet, you will see this needle move. Okay? Okay? Now it's 0, right, Matthew? It's 0. When I go in, do you see it fluctuate a little bit? When I go out, do you see it move a little bit? You have to come closer because I cannot do this. This would actually affect the apparatus. So this go in, go out. What do you see? Okay, after you have seen it, can you go a little back, let other people to see? If you haven't seen it, can you come closer? Okay, in, out, in, out. What do you see? And what is a pattern? What is a current pattern? When I go in, it goes negative. When I go out, it goes positive. Okay, very good. Guys, can you come back here again? Guys, so I hope everyone could see. Heidi, I hope you see as well that there is current. There is current generated from this wire. So basically what I did, I generated the electricity, which is electrical energy. And of course, I use my own kinetic energy to pay for that. So what we care the most today is not only electricity, because that's what everyone learned in year 9, nothing exciting. The most exciting part is you can predict the direction of current. Okay, so now take out your right hand. We have got the B field here. How should we point the B field? North to south. right? North to south, so I have the second finger north to south, so pointing this way, yeah? And if I have the wire going in, how should I move my fingers?
Like this.
Moving in, then my thumb, if you remember, the thumb is the force or the motion, move in. How is the current? Going down, right? So let me try. Trust me, or if you can't see it so precisely, if I move in, Richard, can you tell me the current? Negative. Is it negative? Negative, right? Okay, negative. So guys, trust Richard or trust me, is negative. So negative is here. That means the current must go to negative. So this is downward.
Sure.
Is that convincing? I hope it's convincing. Right? And when it come out, Richard, help me to see. Which direction? Okay, do it again. Positive, right? So if positive means this is going up, right? Going up. You can try with your right hand again. B is north to south. And how about the thumb? Out, right? So current go up. So this match with the results here. Is that okay for you? Is that okay for you for this part? Okay. So now we'll go to the other side.